This is probably one of the best repairs on a Sony Bravia's faulty screen. See the appearance of the on-screen display? Bars start to appear according to what's showing on the screen. It's a 50-inch panel made by AU Optronics. Getting down to business. It's easy to draw the conclusion that this problem can't be fixed, especially if it had been worked on in the past. But because we endeavor to leave no stone unturned, we always verify gate signals. As a troubleshooting rule for this kind of problems, we'll check gate output first. Six test points, HC1 to HC6, should each read around 1.3 volts. That's a bad gate output. Gate signals chip's temperature seems too high for the short duration it's been on. To help you see that, we'll use a thermometer. The temperature of same IC that's good is shown later in the video. That's too high. It's confirmation the chip has failed. Now from experience, we know that a common root cause of this chip failing is a short along gate lines on a COF. Let's see if same has occurred. There is indeed a burn on the left side. Now let's see what a good gate chip looks like. Temperature check. That's a whole 10 degrees lower. So next, we replace the bad gate IC. We can use one from this scrap PCB. Now to the soldering station. Desoldering the bad chip. Extracting a good one from the scrap PCB. Installing the good one. Cleaned and polished. Before we test though, gate signals to the left side of the glass must be cut. The bad chip. Now we see if the display is perfect. Please give a thumbs up if it's good. Finally, let's see how the IC reads now.
Branch, then branch again and again at increasingly smaller sizes. Mathematicians studying this concept of self-similarity use the term fractal to describe a shape that has a consistent, repeated pattern at multiple scales. Where else can fractal patterns be seen in the natural world? Trees can demonstrate a degree of self-similarity. The trunk splits into limbs, which split into branches, then twigs, and so on. we see a similar type of fractal pattern in the leaves of a fern. A different type of pattern, but one that is also a fractal, can be seen in the shell of the chambered nautilus. As it grows, the nautilus builds new, larger chambers and seals off the older, smaller ones that it no longer needs.
It's all good.
The result is a spiral that is fractal in nature, maintaining a similar shape as it increases in size. Natural spiral patterns of this type can be observed in many places, from the cloud formations of a hurricane to tiny shells on the beach, from the arrangement of the stars in a galaxy to the seeds on a sunflower head. What causes these spiral patterns?